Let's look at day 4 camp cleanup from Advent of Code 2022. Hey everyone, this is KeyStrokes. I'm a senior software engineer at one of the FAANGs, and I like to solve LeetCode problems and programming challenges like Advent of Code and just anything and everything about computer science. Today we are taking a look at day 4 of Advent of Code 2022, which is called Camp Cleanup. So continuing with the story, last time we reorganized our rucksack, and today we are trying to clean up the space before the last supplies can be unloaded. The cleaning up has been assigned to several elves, and each elf is assigned a range of section IDs. But as the elves go through their assignments, they realize that many of their assignments have overlaps. So all the elves come together and they create an input like this, where we have assignments from 2 elves in each line, and each item represents a range of sections that's been assigned to an elf. In line 1 we can see the first elf is assigned sections from 2 to 4, and the second elf is assigned sections from 6 to 8. And visually, this is how it looks like. In these assignments, if you look closely, there are 2 pair of assignments which are completely overlapping. The first one is this, where the second elf's assignment from 3 to 7 is totally overlapping in the assignment of the first elf through 2 to 8. Similarly, in this assignment, we can see the first elf's assignment is section 6, which is completely overlapped by second elf's assignment, which is from 4 to 6. So given an input like this, we need to find the number of all such pairs where one assignment might completely overlap with the other elf's assignment. So let's copy this example input that's been given to us. So jumping to our IDE, here I have day 4 already created. We have this input file here. Let's paste what we copied from the example, and then let's open solution.js. Now here we are reading the input file using fs. So we read the file, we convert it to a string, and then we split it on new lines. And then further on each line, we split them on a comma. And here we are logging whatever we parsed as interval pairs. So let's run this and see how our output looks like right now. So running it using node, then solution, we can see it's a 2D array where the first element is the first interval and the second element is the second interval. So let's run a for loop on these interval pairs. So doing for let intervals of interval pairs, and then reading the first interval, which we can read into interval 1, and do intervals, read the first one, and then we'll split it on the hyphen, and then we'll map it to a num, and then convert it to a number using the plus operator. We'll do the same for interval 2, and let's try to log this and see what we get. So logging interval 1 and interval 2. Running this program, we can see now that this is parsed into individual intervals, and this needs one correction. For the second interval, we need to read the first index. So running this program again, now we see it's being read properly. The first output is 2, 4, which matches here, and the second one is 6, 8, which matches here, and so on. Okay, so now the first thing I'd like to do is arrange these intervals so that interval 1 always starts before interval 2. And for that, we can write a simple if statement. If interval 1's start section is greater than interval 2's start section, then we should basically swap them. So writing the classic swap operation, assigning interval 1 to temp, swapping interval 1 to interval 2, and then reassigning interval 2 as temp, which will make it interval 1. Okay, so next we'll create a function which will check if the intervals are subset of each other. So let's call the method as check if interval subset, and we'll pass interval 1 to it first, and then interval 2. And let's store this in a result. Okay, so now let's create this method. So creating a function, check if interval subset, and the first input it will take is the first interval, which is the early start interval. So let's write it as early start interval. And when I say start, that's basically the section that's appearing before. And then we'll have late start interval. Now let's define all the different cases that are possible for the early start interval and late start interval. So let me add some comment here. So let's say if early start interval is represented by these hyphens, then in this case, the late start interval can start from where the early start interval starts, and it can end in middle of the first early start interval. Now we can have another case where we have the first interval and the second interval just goes beyond the first interval, but both intervals start at the same section. Then we can have a third case where we have this first interval, and then the second interval starts in middle of the first interval and it ends before the first interval ends. Then we have a fourth variation where we have the first interval again, and now the second interval starts again in the middle of the first interval, but it ends after the first interval ends. And then we have a final case where we have the first interval, and then we have a second interval that starts after the first interval ends, and then it basically ends after first interval as well. Now for these cases, we know that this one is a subset, so it should be a true. The second is a subset as well, because the first interval is a complete subset of the second interval. Similarly, for the third one, it's again a true, because the second interval is completely a subset of the first interval. This one is a false, because they just overlap and are not complete subset. And then this one is a false as well, as they don't even overlap. Now to write the coding logic for it, let's first talk about the first case here, where the start of the intervals are the same. So writing the if statement, if the early start intervals start section is equal to the late start intervals first section, then they basically represent the first two cases, and we should just return true. Otherwise, we can only return a true if the first interval's end is happening after second interval's end. So basically doing return if the end of the first interval is greater than or equal to the end of the late start interval. So for this, we only capture this case because the end of the first interval is coming after the end of the second interval. Whereas for these cases, we can see that the end of the first intervals is coming way before than the end of the second interval. Okay, so let's go back down here. We see that we call check if interval subset, we pass the intervals, we get the result. Now we need to check if the result is true. If it is, then we should increment our count. And we need to define a count variable. So we can do let count equal to 0. And then after this is done, we can do a console log of the count that we have counted so far. So running this program for the example, we can see the answer is 2. And I think that's what we saw in the example as well. There were 2 such pairs. Now taking the actual puzzle input, so copying all of this, going back to our IDE and pasting it in our input file and running this. We see the answer is 540. So let's put it back in Advent of Code and see if this is the right answer. And yes, that was the right answer, and we got 1 gold star. So let's go to part 2 now. So now in part 2, we need to figure out which pairs overlap. So in part 1, all this time we were trying to find if either of the intervals were a subset of one another. But in part 2, we are interested if they overlap even for a few sections. So for example, for this pair, we have 5 through 7 and 7 through 9, and they overlap in a single section of 7. Then we have another example, 2 through 8 and 3 to 7, which overlaps in all the sections 3 through 7. Looking at the last example, the first interval is from 2 to 6, and the second interval is from 4 to 8, and they overlap in sections 4, 5, and 6. So let's go back to our IDE and see what we can do. So let me first reset the input back to the example input we had. Now going to solution.js. The first thing I'll do is make a copy of this method. And this time, let's say we can call it check if interval overlap. And we can keep the same early start interval and late start interval. And I notice I have a typo in interval. Let me very quickly fix it. So it should be interval, and doing the same right here. Okay, so going through our examples that we had, all of the cases for subset will still be true because if they are a subset, then they overlap as well. Now looking at the fourth example here, we see that they overlap in these sections here. So this becomes true as well. So if we look at the pattern here, we notice that the end of the first interval is always after or at the start of the second interval, given that the first interval starts before than the second interval. And as long as that happens, there will be some overlap. So in this case, this can be as simple as a very simple condition where we return true if the end of the first interval is greater than or equal to the start of the second interval. And that should be it really. So let's incorporate this into our method here. So I'll introduce a new input here. Let's call it part, which signifies if you're solving for part 1 or part 2. And let's add an if condition here. If we are solving for part 1, then we can call this method that we have, check if interval subset. Otherwise, we'll call this new method that we have created, which is called check if interval overlap. And I just noticed that I didn't fix this typo here. So making this interval again and going back to our solve method again. And this time for part 2, we'll use this method for our result and we'll pass interval 1 and interval 2 to it. And let's refactor this further. The result should be a variable, and by default, we can assign false to it. And when we call solve, now we need to pass the part we are solving for. So this is for part 1. and then we have part 2. Let's run this program again, and we can see we have output for part 1, which was 2, and the output for part 2, which is 4. Let's double check if this is the right answer. And yes, the number of overlapping assignment pairs is 4 for the example for part 2. So copying the puzzle input again. So copying all of this, going back to IDE and putting this in our input file and running the program. We got the same result 540 from before, and the new number we have is 872. So going back to Advent of Code and submitting this. And yes, that was the right answer, and we got one more gold star. So this concludes day 4 of Advent of Code 2022. We just solved both parts of day 4, and we have many more days to cover. Well, if this video was helpful, please don't forget to like the video and subscribe to my channel. And you can tip me by buying me some coffee. And please feel free to check out my Patreon that I recently launched for all of the early supporters. You can find benefits like one-on-one conversation with me, getting career advice, and helping me shape this channel further. Well, that's all I had for today. Keep an eye out for more videos. See you next time.